Hello there, I'm Thomas Hatsios, the British American pilot flying the Boeing 777-300ER. It's a nice flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, and then coming back to the Zurich International Airport runway 1449 like localizer lighting. So right now I'm in the cockpit of the pre-takeoff preparation of the Boeing 777-300ER X of the PMGC simulation and Microsoft Flight Simulator X. So I'm gonna start sending the cockpit instruments and the displays of the Boeing 777-300ER aircraft. So I'm gonna start with the primary flight display that displays the airspeed indicated, the ground speed, the airspeed selected from the autopilot and flight director system panel, the radio altitude above the ground level, the magnetic heading and track, and the magnetic north pole and north pole and magnetic variation depending on where we are in the world. We have the altitude indicator with the pitch level degrees and the bank angle in degrees. We have the Lszh localizer and the flight director crossbars for manual guidance of the aircraft, the autopilot crossbars for automatic guidance of the aircraft, the angle of attack of the aircraft, the flight mode and associated with the autopilot and the autothrottle later on vertical navigation modes, the barometric altitude above the sea level, uh, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, and also the vertical speed indicator that displays the rate of climb and descent of the aircraft in 10,000 feet per minute. We have also the navigation display that displays the airport, the waypoints, the navigation aid. We have the terrain and weather radar reflections. We have the GPS position of the aircraft, the RNT and the INT, the required navigation performance and the required navigation performance. We have other aircraft flying around aircraft displayed by the transporter, ADSP and ADC transporter, transmitter, receiver that transmits our own position, altitude, direction, and airspeed to other aircraft, and also airspeeds from other aircraft, and displays their direction, altitude, elevation difference from our own aircraft, and also their airspeed, and also generates warnings using the TICA system, the traffic collision alert system. We have also the magnetic north pole and north pole and the magnetic variation again. We have the wind speed direction and magnitude. We have the next waypoint. We're going to be overflying the ground speed of the aircraft. So you're gonna see all these things. We have also we're gonna generate using the flight management computer a route. We have departure, airport, and runway. The seats, the SADAR instrument departure aids, the waypoints and the fixtures, and also the native waypoints and fixtures, and destination, start, terminal arrivals, and Lszh localizer, runway selection, and airport, destination airport. So we're going to have a complete route for the later on vertical navigation modes of the aircraft using manual flight guidance or automatic guidance using the autopilot and flight director system panel. So you're going to see that. We're going to create a complete route. We're going to input the data of the aircraft like its takeoff weight, the fuel on board, the reserve fuel on board, and also the taxi fuel, and also the passenger and the cargo weight. We're going to calculate the center of gravity as a main aerodynamic core position, and the trim, horizontal trim stabilizer position for takeoff using the flap settings, and the runway length, and also the runway conditions like the wind speed direction, the barometric pressure, the air density, the air temperature, and also other data. So you're gonna have like if the runway is wet, dry, or ice, and also I'm gonna show you that after I'm gonna show you all the systems. We're gonna create the flight plan, the flight path for the aircraft, the complete route. So I will continue then with the autopilot and flight director system panel. I will show you the autopilot engage and disengage switch, the autothrottle left and autothrottle right engage and disengage switch, the flight director engage and disengage switch. We'll have the airspeed select knob for the airspeed guidance of the aircraft, the flight level change, We can select an airspeed over here, and we have some modes for that also. uh, so I'm gonna show you. We have these modes. You can select an airspeed in nautical miles per hour or Mach speed, and select the modes for like a fixed thrust mode or a variable thrust mode. So we have the flight level change, we have the climb continuous, and the auto throttle with the speed mode. So we have the fixed thrust mode for takeoff and go around, and also the maximum climb or the idle thrust for descent. And the airspeed of the aircraft is being adjusted by varying the rate of climb and descent of the aircraft using the horizontal trim stabilizer and the elevator orders from the autopilot and sky director system panel, while the thrust of the aircraft is being maintained stable. And we have the variable thrust mode in which the airspeed is being varied while the altitude of the aircraft is being controlled into a stable level flight. So we have also the LNAV and the VNAV, the lateral navigation and the vertical navigation modes of the aircraft, which are interconnected to the flight management computer input and the flight plan created. We have the bang angle of the aircraft limit for the autopilot when we are in cruise level. We have the heading select mode, the heading hold switch, and also we have the vertical speed mode. We can select the vertical speed in tens, hundreds, and thousands of feet per minute. The VS mode, which controls the vertical speed indicator, and also the flight path angle, trigonometric angle in degrees for climb or descent. We have also the altitude select node and the altitude hold switch. We have the VOR localizer for the Lszh localizer approach, and also the approach switch for the auto run function of the Boeing 777-300ER. Then I'm going to show you the thrust levers. I will explain you how you can control the thrust generated by the engines of this aircraft. The General Electric 90, we have the G90 turbofan engines installed in our aircraft, one in the left wing, one in the right wing for symmetrical thrust and redundancy. So you're gonna see also that. You can see here the thrust levers. I can adjust the thrust produced from the thrust levers position. So you will see displayed over here, which gives a command to the FADEX, the fuel authority's electronic control computers. So we have the FADEX, the fuel authority's electronic control computers installed in our aircraft, one in the left wing engine, one in the right wing engine. The FADEX are the fuel authority's electronic control computers. I will explain you the function later when I get to the thrust levers and the auto throttle and the auto thrust system function. Then I will explain you about the flight theory of the aircraft. I will show you the flight controls of the aircraft, like the yoke, the horizontal, and the vertical control of the aircraft. So you can control the elevator using the control column, and also the ailerons and the spoilers using control wheel, and also the rudder of the aircraft using the rudder pedals. So you can have directional control in steering flight after using the thrust levers for propulsion. Then I'm gonna show you also. We have it here. So I'm gonna show you then the overhead panel, the electrical, the left engine and the right engine, electrical power generators installed in the gearbox of the engine, which produce 120,000 kilovolts or 120,000 watts of alternate current, 130 to 200 volts, 400 hertz constant three-phase current, constant frequency. So we have alternating current from these generators, also 35,000 kilovolts same current and voltage from the backup generators, the left and the right engine. Also we have the APU, the auxiliary power unit, which produces another 130,000 kilovolts, so 130,000 watts of alternate current. mainly for engine start during the golden dark process. We have also the battery direct fuel 3 volts for 3 hours. I'll show you also that. We have the ability data user reference unit, which controls and displays all the air data using like the airspeed, the rate of time descent, also the magnetic north and the true north pole, and the magnetic variation, also the attitude of the aircraft in the GPS receivers. So we have the laser gyroscopes for the aircraft to calculate the acceleration or deceleration rate. So we have all this in the ability that I answer from this unit. We have the primary flight control computers. We have the hydraulic system, left and right engine, driven and electrical, C1 and C2 air pressurized also. Hydraulic fluid tanks, which are supplying mainly the flight controls of the aircraft. The landing gear extend and retract, the parking brakes, the thrust reverse, and other systems. So like this nozzle steering also. So we have also the fire extinguisher for the aircraft. We have the window heat and also the passenger oxygen. We have also the left and right engine electronic engine control for the engines, and the auto start system. I will show you also that. We have the fuel tanks, the center tank, the left wing and the right wing, the forward and the aft pump, the fuel control computers and system of the aircraft, which supplies with fuel using the low and high pressure fuel valves and the profit valves, and the fuel booster pumps, the engine, the left and right engine, and also the APU, the auxiliary power unit. We have also the wing and engine at the ice. We have the cabin pressurization system of the aircraft, and we have the bleed air from the left and the right engine, which pressurizes the cabin pressurization system, the wing and engine at the ice, the air conditioning and ventilation, and also the hydraulic fluid tanks for the flight controls and other system, which receives pressurizer from the left or the right engine or the APU. So we have also the APU pressurizer mainly for starting the engine in the ground or as a backup in flight. So it admits the pressurizer into the engine starter during the engine start process. So I'm going to show you also that how to use the APU, the auxiliary power unit, for starting the engine. So thank you one more time for joining me in this video. Then I'm going to make a small flight from takeoff to climb to cruise to descent and then to approach and landing, a full flight from takeoff to landing using the Boeing 777-300ER. So thank you very much one more time for joining me. I'm Thomas Hatsios, the latest American pilot flying the Boeing 777-300ER nice flight. So I'm going to start now with the ticket instrument. So we have about about an hour left for this video to end. So you can see here also the outside view of the aircraft and also the airport where we are located. So you can see here we have the primary flight display. You can see the airspeed indicator, the airspeed selected from the autopilot and flight director system panel, the ground speed. So this is the airspeed page. We have also the radio altitude above the ground level, the magnetic heading or track, the magnetic north pole and true north pole, the magnetic variation depending on where we are in the world. We have also the barometric altitude above the sea level, the target altitude, the rate of climb descent of the aircraft in tens, hundreds and thousands of feet per minute. And this is the VSI tape, so you can see The needle moves up above the altitude in a positive value in a climb or in a negative value in a descent, like 1000, 2000 feet per minute or 500 feet per minute. So you can see the barometric altitude pressure of the outside atmosphere also. Other data here, we have the magnetic north pole, the true north pole, the magnetic variation. We have the pitch ladder in degrees, the flight director crossbar. So you can see the pitch ladder 2.5, 5, 7.5, 10, 12.5, 15, 17.5 degrees of pitch up and pitch down, positive and negative percent. The bang angle like 45, 33 degrees. So this is most of the display here. You can see also the magnetic north pole, the north pole here. You can use you can switch between true and north by pressing this switch. So now you have the geographic north pole for the navigation display instead of the magnetic, which has some difference depending on where we are. Now we can use again the magnetic, use the magnetic over here. You can set also inches of mercury or hectopascal, the meters. So now we have meters also for display and hectopascals of it. Now we go over there. You can see the autopilot engage and disengage, the flight level change, the flight director on and off. So this is also depressible, as you can see. This switch over here, the other one over there, so you can select an airspeed for after takeoff, like 253 nautical miles per hour or not. You can select the auto throttle left and auto throttle right. You will see auto throttle left over here is off, display with yellow, amber color. Also auto throttle right and auto throttle left is on. You will see the auto throttle right warning over here. We have the flap settings. You can set the flaps up and down over here. You will see it increases the surface area of the wing, so it decreases it. Also the lift from the wings produce the speed brakes. I will come later to that. So you can see the flaps over here, the position. You can see the total fuel on board, 104.4 thousand pounds. The temperature, also the duct pressure from the bleeder. So the cabin altitude rates. So you can see also we have both auto throttles here. So we have also the LNAV and the VNAV. The autopilot disengage, flight level change over here. So you can select a mode now. We have also the select for the heading, the hold, and also the bang angle limit. So you can select a heading of 136 degrees, an altitude, different altitude over here, variation. The altitude hold, the vertical speed, flight path angle. So you can select a negative flight path angle for a descent from a cruise level, for instance. You will see here minus 2 point something we have selected, minus 3.5, 35,300 and 253 nautical miles per hour. So this is minus 3.5 degrees in between minus 5 in the pitch ladder. As you can see, for a descent, we have the flight director on. So this is not gonna generate anything right now. You can select a positive value here, like again plus 3.5 degrees. As you can see, the slider moves up or down, so you can change the value, the input value. So we have now the pitch altitude here for after takeoff plus 3.5 degrees. (253 nautical miles), again 7,710 meters. Perhaps we can select the autopilot on right now here. You can see autopilot on, autopilot off. You'll see autopilot disconnect if you press like this the switch and the warning here, the oral warnings. So we can reset again, reconnect the autopilot, will cancel. So now we have the autopilot connected for this target altitude and this climb rate, 7,710 meters, fly path angle, heading hold, and 203 nautical miles per hour. From this takeoff altitude of 1,436 hectopascals, again we can set inches of mercury. We have also the vertical speed. We have the rate of descent with a negative value from this cruise level. We will show you here the target, the magenta over here, 2,500 feet per minute, the stick mark for a descent. Now we'll use a positive climb over here, like 3,500 feet per minute. So we have the positive climb over here, 3,500 feet per minute. For this target altitude, again this target the VS over here mode. So we can select again the altitude mode again instead of selecting this, which is also depressible here. This mode also you can deselect like this, select another value, and then the hold. So now we have the heading and the altitude together. So you can see 7,710 meters, so 35,300 feet with the altitude, and also we can have the flight level change speed mode for nautical miles per hour max speed, like this. Flight level change. So we have the climb continues, the auto throttle, the LNAV, the VNAV. This is also the pressure, as you can see. So these are all the modes for the autopilot and flight director system panel. Maybe a few more using the thrust levers function. We have the flight level change speed with the autopilot on. So now we can disconnect the autopilot. So we have 30 minutes already gone from this video, so we disconnect the autopilot like this. Press this out, you will see the warning here, and also we have the autopilot disconnect here with red letter. So reset again, the warning is gone. We can reset again, press the autopilot on again one more time. So we can just use the autopilot disengage over here, this button, press one time, you will hear the warning. We have the autopilot disconnect over here in this display. Press one more time and you confirm the disconnect action like this. So now you have full flight controls manually after you disengage the autopilot. So now we'll show you the rest of the systems very quickly. So I believe we have, you can see here we have the speed brake. As I told you, you can extend the speed brake when the thrust levers are at idle. So you have also a few more things here. You have the fuel flow control for the left and the right engine. This is the left and the right engine thrust levers to control the thrust produced from the left and the right engine, the General Electric 9200 engines, as I told you. Here you have the auto throttle disengage switch. Disconnect the auto throttle like this. Press one time and you disconnect the auto throttle. The takeoff go on. You have the speed brakes are retracted. If you want the thrust reverse, this is the thrust reverse action. We'll extend the thrust reverses. So you can slow down the aircraft after touchdown in landing or in our ejected takeoff. So this extends also the speed brakes automatically. You can see the speed brakes extended. So here we have the thrust reverse on. You can cancel, you can extend again one more time. Also the forward view over here, cancel, retract the thrust reverse and the speed brakes. Also the other side, retract and extend again. So this is how you can use all the thrust reverse. Slow down this airplane after a landing in the touchdown or in our ejected takeoff. After this, so you cancel the thrust reverse. Also, if you have the idle setting for the engines, you can extend the speed brake. You can see the speed brake here. Also the trim, the normal and the alternate for the horizontal trim. This is also, I told you already, is the flaps position. You extend or retract. Now you retract. Now you extend the flaps. So you have also here is the parking brake, extend and retract. The horizontal trim stabilizer of the horizontal tail. So here you have the autopilot disconnect. Besides that is the horizontal trim stabilizer. You can pitch up and pitch down the horizontal tail of the aircraft to maintain stability in flight. The aileron trim also. So you can see the horizontal trim stabilizer. You can set it also using this, the nose up, down and nose up. And you will see here nose down or nose up trim orders coming up. You can see we move this needle. This is the green band for takeoff settings. Also here is the rudder trim indicator and the aileron trim. You see over here the aileron trim indication. So if you move the horizontal tail trim stabilizer for the horizontal tail of the aircraft, you see back here. This is the horizontal and the vertical tail of the aircraft, as you can see. And this is the ailerons movement. So you can set to trim all these surfaces. So now we have the horizontal trim stabilizer. If you have a failure of the autopilot uses the automatic trim stabilizer setting. Also the auto throttle when the aircraft is flying. So you can, if you have a failure of the C or the R, this is the hydraulic system. You have the C and the C1 and C2 air pressurized and hydraulic system pump. So if you have a failure of that, the auto trim system of the autopilot and the auto throttle will fail, so you have to disconnect the stabilizer from the normal to the cutout. So you do a reset like this, or you disconnect completely. So this also here is the fire extinguisher for the left and right engine. Now I'll show you everything around the engine. I will show you now the thrust levers. So now you can see we have the thrust levers forward, the left and the right. So now we can use differential for thrust, like the right wing engine. You can see differential thrust over here, more engine produced for the right wing and less for thrust for the left wing. So now we can set both the same or either. Now we'll set the other side engine. So you see the differential thrust component over here, the right, now it's the left wing having more thrust while the right is at idle. So when the thrust levers are at idle, you can extend also the speed brake. When you move the thrust levers with the speed brakes extended forward, the speed brakes also retract. So you can see here the indications displayed by the pharex. The pharex are the full authority electronic digital electronic control computers that display all the engine information. You see like the N1, which is the low speed starter and shaft of the left and the right engine. You have the green maximum takeoff thrust over here, 104.6%. Maximum continuous thrust, also the yellow and the red and the green limits. So you have the N1, which is the low speed, low starter and shaft, and low pressure compressor and turbine of the turbofan turbocharged engine. The exhaust gas temperature, other indications not related to the engines, the flap settings, also the fuel on board, not related to engine, the duct pressure from the left and right engine, and PSI, the bleeder. Also we have the N2, which is the high speed starter and shaft, the high pressure compressor and turbine left and right engine, the fuel flow per engine per hour, the oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engines left and right. So you can see when I move the thrust levers around, you can see the indications displayed by the pharex. There is some difference between the commanded thrust lever position and the actual. It takes some seconds for the engine to spool up or spool down. So you have to anticipate that when you're flying. Anticipate the thrust lever's position and the thrust you need before you're gonna need it. So you have like this the thrust lever's position. So you actuate or adjust the thrust lever's position and give a command to the pharex. The pharex are full authority electronic control computers. One is for per engine, one the left engine, one the right engine gearbox. We have the General Electric 90 G90 engine, turbofan turbocharged engine. So this is a turbocharged aircraft. One in the left wing, one in the right wing. For symmetrical thrust and redundancy. Also, the pharex have symmetrical dual channel redundancy. One channel fails, the other takes over. So the turbofan engine produces a lot of thrust. So when you move the thrust levers, you adjust the thrust. You give a command to the pharex that control and monitor and display all the indications using the upper and the lower ACAS and the indication equivalent system display. Like the N1, which is the low speed starter and shaft, low pressure compressor and turbine of the turbofan turbocharged engine, the exhaust gas temperature per engine, the bleeder pressure from the left engine and the right engine, the fifth and the ninth stage fan blade stage in the rotor shaft. So we have also the N2, which is the high-speed starter inside the high-pressure compressor turbine of the turbofan diluted engine. We have the fuel flow per engine per hour, the oil pressure, oil quantity, oil temperature, and the vibration of the empty states of the engine. So we can see also we have the Firex control and monitor all the data you see, also the engine start, engine shutdown, the fuel flow rate and the fuel air mixture, also the pressure inside the engine. So we have an overpressure, we allow the open the fifth and the ninth stage the outflow valves into a higher position, so we release the overpressure from inside the engine. Also, we have another pressure, we can close the outflow valves into a lower position so we can increase the engine pressure. Also, we have from the sea level all the way up to the cruise altitude, like 20,000 feet, 30,000 feet, or 40,000 feet above the sea level. We have difference of barometric pressure, air density, and also temperature. So we have about half the barometric pressure and half the air density at cruise level, and also we have freezing temperatures from way below the zero. So also the aircraft flies on a higher airspeed rate at higher altitude. So we have different air fuel mixture requests every second. So this is adjusted by the Firex fuel, so it is electronic control computers. Instead of doing manually every second, we do this automatically. So we adjust the fuel mixture and the fuel rate calculations, and we adjust also the redundancy and the fuel efficiency of the aircraft. So it's a good thing to have the products installed in your aircraft. Also the engine start, engine shutdown, and the engine failures. So I will talk to you about the flight theory of the aircraft, about how it takes off using the thrust levers, thrust producer, and also how to calculate the takeoff speed. So for this aircraft right now we have 254,000 kilograms of takeoff weight, or 521,000 pounds, which is way below the maximum takeoff weight, and we have about 30% of fuel on board, or about 46,000 kilograms, for about 102,000 pounds, and we have about 30,000 kilograms of passenger and cargo, about 36,000 pounds. So in total 254,000 kilograms for 531,000 pounds. We need to use 15 degrees of 15 degrees of flat, and about 4 degrees of positive for zero trim stabilizer for takeoff, using this runway length and conditions like wind speed, barometric pressure, and density of the air, and also the temperature of the air, and if the runway is wet, dry, or ice. So we're gonna need to take off at an airspeed of about 154 nautical miles per hour, or 154 knots, or 270 kilometers an hour. Just to take off, we need to overcome the slow speed of the aircraft. We're gonna make the aircraft fall back into the ground. So we need to overcome the slow speed during the whole flight. We need to have the effective lift from the wings, using the aerodynamic flow from the airstream created from the forward thrust propulsion and the attitude of the aircraft. The wings, so we have I will explain that outside. So I will show you, I will talk to you about the Newton's first, second, third law of kinematics of motion, about the behavior of physics of fluids, also the nautical and aerospace engineering, and I will derive some interesting explanations about the flight theory of the Boeing 777-300ER, and about the flight control systems and how to use it. So I will show you now the outside view. Doing that, you can see here we have about so you can see here we have the outside view of the aircraft. So we have a few more minutes for that. So you can see we have the wings of the aircraft hold the weight of the aircraft in total. The surface area, you can divide the weight of the aircraft over the surface area of the wings. We have the left and right engine, the forward thrust propulsion vectors component move only forward the aircraft. We have the wingtip to wingtip, the lateral axis. We have the nose to tail, the longitudinal axis, the transversus, also the center of gravity, the vertical axis. We have the mean aerodynamic chord position here, the Mach 25% of the mean aerodynamic chord. This is the position where the maximum aerodynamic lift, also on the center of pressure curve, and also where the stall of the airflow above the wings of the aircraft starts or begins, so the airflow becomes detached from the top of the wing as the aircraft flies. You can see also we have they told you the center of gravity is in positioning about the same position, forward or after the mean aerodynamic chord position. So you have symmetrical weights and forces around the aircraft. We have also the lever arm, which times or lever arm or moment arm, using the horizontal, the vertical tail, and also the ailerons and the spoilers, the deflection from the airflows. So it's times the lever arm is times the distance from the center of gravity all the way back to the horizontal tail over the surface area of the horizontal, the vertical tail, times the airflow of the air mass per second, times the elevator deflection up and down, or the rudder deflection of the ailerons and the spoilers, and times the acceleration of the earth gravity depending on where we are in the world. So you have the force that can pitch up and pitch down the aircraft, and also make it turn left and turn right. So we have also here, you can see the wings of the aircraft that produce the aerodynamic lift holding the weight of the aircraft. So this is the bottom surface of the wings. You can see is more flat than the top, so the airflow of the air mass as the air travels forward, from the forward all the way back, from the leading edge to the trailing edge, the airflow moves slower below the wings, so we have higher air pressure, which pressurizes the wings up into the air, a positive air pressure below the wing. Also we have the top surface of the wings, you can see is more curved than the bottom surface. It has higher curvature, so the airflow, using the Bernoulli theory of fluids for the bottom and the top surface for the airflow. So the airflow moves much faster above the wing, so we have lower air pressure and air suction above the wing. It sucks the aircraft wings up into the air, and you can see also, so this is negative air pressure above in the top surface of the wing. So this is all the explanations for this. I will come now to other data of the aircraft and other stuff like the flight controls. So I will show you how to use the flight controls for controlling the aircraft in flight. So I will show you how to use this side stick for controlling the flight controls, like the horizontal elevator, the vertical rudder, and using the rudder pedals, the elevator using the control column, and the other spoilers using the control wheel for having directional control and stability in flight, and also use the horizontal stabilizer and the thrust lever. So I use this side stick here, the Logitech Extreme 3D, so you can see. So you can see you can see in the screen I can pitch up and pitch down, climb or descend. Also the other side is interconnected and moves proportionally to the side stick deflection, both sides, as you can see. So you can also bang roll left and bang roll right using the ailerons and the spoilers, and also use the rudder pedals. Also the horizontal trim stabilizer over here, and having the thrust levers up and down. So you can move the thrust levers up and down, and you have full control of the aircraft like this. So I hope you like it. Bunker left, bunker right, and the thrust levers. It's actually the thrust propulsion. So you can leave neutral also. So this is the general principle for using the flight controls, and I will show you outside. The outside view of doing the same thing. So you can see the side stick movement is proportional to the yoke or the flight controls movement. So again, we come over here. The side stick again, controlling like making left turn or making a right turn like this. Also climb and descend, left and right rudder pedals. This is the flight controls again movement, left and right turn, the rudder cutoffs and the elevator up or down, pitch down also. So come again inside. So here you can see we have the overhead panel. We have the view of the cockpit over here. So we have a few more minutes for this. We have like 6 plus 3, 9 minutes. So I will start here with the casings. You can use the flaps up or down. So I'll set them at 15 degrees over here. You will see 15 degrees displayed over here. I have to move them down again to the 15 degrees position. We have the speed brakes again, and retract, the parking brake up and down, the horizontal trim stabilizer, cut out and normal, the fuel control for the engine. So you see the displays again, you see the autopilot here, everything is set correctly. So I will set here, you can see the air data notes, a reference unit. I told you that displays all the air data like the airspeed, the barometric altitude, the GPS receiver's position, the rate of climb, descent, and also the magnetic north pole to north pole. All this is done using the ADIR, also the gyroscopic laser gyroscopes. We have the thrust symmetry compensator, primary flight control computers, the electrical, left engine, right engine, backup generators, also the APU. So we need to start the APU. We have the battery on already, as you can see. We have the passenger oxygen, the ground proximity, the window heat, the rammer turbine, the left and right engine, hydraulic fluid. So we can turn off all the hydraulic fluid tanks. You will see some warnings being generated. So you will see the faults here and here. We have alternate flaps now, and all this hydraulic systems, the stabilizer, primary flight controls, the demand C1, C2, also C1, C2, CNR fail. So we need to reset the hydraulic to be on. from the full position, so we set back to the auto. This is also the lighting system of the aircraft, the left and the right wing windshield wipers. This is the hydraulic fluid cutout switch for maintenance on the ground. The circuit breakers you can use for resetting some systems if they fail. We have also the fire extinguisher for the cargo and the APU, the electronic engine control for the engine, normal and alternate, the auto start also. You can use the auto start on and off like this. So we'll leave the auto start on. You can dump some fuel if you want to decrease the weight of the aircraft. Select how much to remain and the tank to jettison. You have the center fuel tank, the left wing, right wing, and the crossfit valves. You can see the center tank is empty, the yellow press message, and the forward and the aft fuel pumps. The wing and engine DI system. The cabin pressurization here. So we have cabin pressurization, auto, manual. You use the outflow valves for climb and descent to open and close to pressurize or depressurize the cabin of the aircraft and select the landing altitude. Also the left wing and the right wing bleeder and the APU we need for starting the engines in the ground. So I will show you now what happens if we turn off all the bleeder. APU is running. So this is all the resets. Now we have back the pressurizer. So we go now over here. I will show you also one last thing before doing the engine start. We have the system, so you can see the engines, the status, the APU is running, hydraulic fluid, the passenger oxygen, the checklist, the normal menu, what you will need to do before before start. You need to complete all these items. Also, if we have normal failure, communications, navigations, synoptics, the doors is closed and the cabin is pressurized, the landing gear. You can see the gear, the pressure inside the tires and the temperature of the brakes. The electrical, you can see the left and the right engine driving, the backup generators, the battery voltage over here, the APU battery, and the APU is running. So we have also the hydraulic fluid, left engine, right engine, the center C1 and C2, which is also pressurized by the air system. The PSI, have the center tank, the fuel system here, the left wing, right wing, left and right wing tank, the engines, left and right engine, the APU also fed from the left wing tank. You can see the minimum fuel temperature where the fuel freezes over here. The air system, the bleeder from the left and right engine, also the APU, and we have also the flight controls here, the last system. You will see extend the speed brakes, and also whatever you do here, it will so you have an impact in the display. So this is the last thing you need to see. Also you have the trim stabilizer for the horizontal tail, and all the movements, all the flight controls are correct. So we'll go back to the engines. We need to set the start of the engines. Make a small auto start like this, left and right wing, also the lights, exterior lights. So you will see some resets is happening here in the auxiliary panel. Also here the indications, we have engine shutdown over here, engine auto start left and right. As you can see here, the indications for the auto start. So we have also into and the fuel flow is 0. So the turbofan engines of the Boeing 777 we're gonna start now because we have them already in the auto start position on. The N2 is above 30%, so we can let the fuel flow back to the run position. So you'll see the fuel flow increase rapidly from 0, and you'll see the turbines over here moving very quickly, because now we have both pressurizer and fuel inside the engines. So one last thing left to do before going out for takeoff. We need to set this, the FMC, position initialize Lszh, reference airport, set inertial position, the 0 fuel weight, gross weight, the fuel on board reserves, the cruising altitude 35,300 feet, and the coast index 100%, the minimum fuel temperature for cruise, also departure and arrival Lszh, the runway 14, departure 14, transit to Alpha, and arrival Lszh 14, Alpha transonic. So we have this set, activate and execute, and we have only the flaps 15 degrees, the center of gravity 36% with 4 degrees of horizontal trim stabilizer, and the takeoff stage for this gross weight and this runway, and we are ready for takeoff. Everything is set. Disarm the parking brakes and advance the thrust levers over here. So this is the runway, and we go in the right side over here. So you can see we take the runway takeoff clearance, the traffic control clearance. You can see the runway is empty. So we use this pillar for the nozzle steering. Again, nozzle steering. So we align with the runway. Parking brakes again. Set the range here. You can see also the flight plan displayed, and the LNAV here. The trim stabilizer is set, the flaps are set. So we set the thrust levers here, the thrust for takeoff. So one last look over here where we are and where we go before takeoff and then coming back. So we have a nice closer view. Disarm the parking brakes and go. So we have about 15 more minutes for this video. So we have V1, V rotate, and V2. So we have the positive rate of climb. We track the landing gear. So we are here 700, 800 feet above the ground level, 1000, 2000 feet, 2900, 3000 above the sea level, but 1000, 2000 feet above the ground. The airspeed 200 knots. We keep climbing, so we need to decrease the pitch altitude here as we keep climbing. And this is the climb bar. So you can see also the stall speed here, the yellow marking 145 to 130 knots. So we climb with maximum takeoff thrust, and we have about 14 minutes left for this video to end, for this video record time. So we keep rotating here, keep rolling. So I'm gonna show you again this nice view of the Boeing 777. Now we need to pitch down, decrease the rate of climb. So we have this beautiful view here. We keep flying with about 500 kilometers an hour, or about 250 meters per second. So this is the nicer view here of the Boeing 777 with its wings, its engine, as we keep flying and climbing. Now we have these beautiful views here. Now we need to steer again. So we crossed the first waypoint, then the second waypoint. Keep climbing, 30,000 feet. And we have pretty much 8 and 10 minutes left for this flight. Then we need to cross the next waypoint over here. Maybe 2,000 feet. Maybe 3,000. So now we're gonna have the chemtrails and the contrails. Hope you like them. We're flying now with 250 meters per second. Our flight level of about 33,000 or 7,000 meters approximately. So you can see the galaxy view. So this is our spacecraft for tonight, the Boeing 777-300. We have this beautiful jetliner aircraft. So we have the Zurich here, we have the Germany in front of us, and the Bavaria, the Bayern Munich in front of you, the Switzerland, the Swiss out here, and the France on this side. So Germany and Bavaria, we're going this way. We have also the lake, the St. Gallen Lake here. You can see the frozen vapors as we cross the galaxy, and now we need to start sailing back into the airport. So we're not reached yet the cruise altitude. We need to set higher airspeed now. So we keep cruising here, 35,500 feet, and you have the Germany on this side, the Bavaria, the Bayern Munich. So this is Bavaria on this side, Germany, and the France this way, and we go back to the Switzerland. So we have this full nice view of the Boeing 777 cruising at 35,500 here approximately. This nice view, and you have also the galaxy again, a beautiful view of the galaxy. So we need to achieve this altitude here. Perhaps connect the autopilot just for display as we reach the level cruise flight now. And we have flight level change and the LNAV on. So we can see how we can use the autopilot now. So cruising altitude over here. As we navigate back to the airport here, and we maintain this cruise altitude. So maybe we need also to calculate the last waypoint direct to, and the landing speed of the aircraft. So now we're cruising 35,300 stable, having the autopilot on. So we have this altitude now for the aircraft. So we have again the galaxy, so this is our first airport tonight. We fly with 980 kilometers an hour or 300 meters a second, or Mach 0.77, about 7,700. 10 meters above the sea level. So we need to start descent. So we decrease the altitude now. Also the airspeed with the flight level change, and the vertical speed, and also now this will change the command. We use the speed brakes for descent. So we have the descent now over here. Again, this beautiful view with the galaxy over here. As we keep descending, of the Boeing 737. So we have about 4 minutes left for this video time frame. We can decrease also we need to disconnect the autopilot and the manager. So this is how we keep the setting. So we have about 3 minutes left for the video to end. Hope we're gonna record the landing. So we need that to come closer. We have the runway in sight. We will find the river here and increase the rate of descent. You can use manual thrust if you need. So here we are, much closer to the runway. We need to add some thrust and also increase the rate of descent. So you can see where we are. We have the Lszh localizer on. You can see all the information. We are above the glide slope and we are aligned with the localizer, the airspeed, the rate of descent. So we need to level off now. Also use the ailerons and the spoilers, the elevator and the thrust levers to adjust the airspeed. We need to level off. And idle thrust now. So leveling off now. 30. Idle thrust. 10. Here we are. First touchdown. Parking brakes and reverse thrust. Full reverse. And here we are, just landed. The airplane, we have the next taxiway in front of us to exit. So we just landed. You can see everything is normal with the airplane. You can see the nose wheel here It's perfectly normal. There is no breakage of the metal parts or bucklings or the tires, no broken tires. So you can see also the front view, also the back, the landing gear over here, the left and right landing gear. There is no breakage of the wheels or the tires or buckling, the left and the right landing gear. So you can see the aircraft is standing up the way it should be in its wheels, also the forward wheels over here on this side again. So we made a very smooth landing here, as you can see. No breakages, like some other pilots doing with their airplane.